last time I told Anna that I'm not uploading any videos on the YouTube channel. Oh, okay.
Sorry, I always forget it does that.
Yeah.
um,
So,
yeah, you told Anna that you're not uploading, right?
yes, but actually, if you wanna, I can continue uploading. For me, just a matter like of a few minutes, like 5 minutes. So, and I'm not uploading because we have no such requirement anymore. But
Okay.
I can do that. What do you think?
It's up to you. Yeah, if you end up posting them, just let me know, and I can upload or update the website because I have links for every
Oh,
YouTube video in there.
oh, okay, okay. Then I'll do that. Absolutely.
Okay.
Okay. So, and I guess you need some time to upgrade your repository, right? Because I created a new one and I sent you the link, the invitation link.
Oh, yes, yes, yes. I have not. I've been doing more like writing stuff for the
Yep,
paper, the assumption stuff and the that Marco mentioned.
yep.
Uh, yeah, I have not tried to do the new repo, getting it to work, but I can do that
Okay,
um,
perfect.
to see if BirdNet's going to run on my machine. Um, what else? And I looked through the data that you cleaned already, right? That you sent, but I need to do the analysis on that. But I've honestly just mostly been going through looking at assumptions and limitations. I put the PDF right before this meeting on the Teams channel so that if Anna or Marco want to take a look, maybe they can give us some.
Okay, I got you. So I've done a little bit of analysis, and I can
Okay.
go through the analysis. One
Okay.
second. Okay, 1 second. Okay, let me share the screen. Yeah. What? Wait. Oh, that's the one. Yeah. Okay. So that's the analysis, right? So basically, okay. We can run. Let me detect. So I created some functions, and all these files are on our repo. So you can
Okay.
just go to my branch and take a look.
Okay.
So the functions. Oh, what's up? Okay. So like let me just. So this is sorry. This is to get the basic information about dataset. This is about defining who appears before and after Hume's Warbler. And I've just ran 3 seconds, which is
Okay. Nice.
probably okay.
Yeah.
That's to see who's singing like continuously, like
Right.
3, 6, 9 seconds. That's the function to explore the data set. I was just like running like some, mm, um, common, common metrics, like not metrics, but common um, features like unique values, value count. So just to see like what we can find out in the data. And also about the accuracy of the data set.
Mhm.
So last time Anand was talking about defining the lower, like the lowest and the highest um, boundaries for accuracy, but actually we might use this one. So basically, by the accuracy in this script, like snippet, we are calculating the mean of all the levels, let's say, and then we can see what is the average mean of the data set, and the mean
Mhm.
of the data set includes zeros and ones of the evident. So like it just show us, let's say, like if the confidence level is 0.5, so and I can show you later on. And if the average is, let's say, 0.7, it means that at the confidence level 0.5, we at least sure that 70% of the class habitant 1 and 0 is predicted correctly, like in 70%. So and
Okay.
when the confidence level goes higher, the average it also goes higher. And at some
Mhm.
point, I'm gonna show you later on. So like the confidence level and the average or accuracy, as we can call it,
Okay.
are almost the same.
Okay.
Yes. Okay. So also these functions is was to define uh, group the species who are singing at the same time, so like groups.
Mhm.
Like as you remember, like at the same time we have like mostly pairs. Actually, one of the chunks, 3 second chunks, has three birds singing together, but mostly it's all the pairs. So like
Okay.
the process. Okay, like one second. I guess yeah, it has all the information. So pre-processing data. So you just read the data the I sent you, the one like that has all the information. Also, I dropped columns, um, a named scientific name and year. Year is redundant
Redundant, right?
because it's 24. So scientific name and common name, they are also like, I mean, we can include the scientific name or common name. In my case, I just got rid of the scientific name just to make sure like the data it's less. So in this case,
Right.
we just kind of saving the computational cost.
Right.
And also unnamed, it was the column of indexing the observations. So I
Ah,
just
okay.
drop them.
Okay.
So and I split the data into different subsets. So the data itself is data O5, confidence level O6 is O6, O7, O9, and O9, and O8 and O9. So in this case, we kind of know which data set we are working with. So and I printed the accuracy. Do you remember like the accuracy function? uh,
Right. What
yeah,
you said
right
earlier.
here.
Right.
So yes, it just showed us what is the
Okay.
total accuracy. So yes, like at 0.5 confidence, right? We can see right here. The total accuracy is 0.7756, where the accuracy of all habitants is all like class 1, right? It's
Mhm.
0.77, and for non-habitant, we can rename it if we need it, or zero class is
Mhm.
0.697. And it just, I'm sorry, it in accuracy print. Okay. Yes, and then it goes zero point 0.6. Here is wrong. I've just corrected. Yeah, let's just run all. Yeah, so like yes, you see. So like the total accuracy is 0.815, and it go and so on. So the higher confidence level, the higher accuracy or the higher average of the all confidence levels are in the data set. So now we have to understand which confidence level we have to work with. So I plotted total, so like the observations by confidence levels, right? Like total, evident, and non-evident. So in
Mhm.
our case, evident is 1 and non-evident is 0. And that's what we have. So let's say like the total, it has like a little bit more than 200K observations at 0.5 level. And it goes to 50K at 0.9. And green is like almost the same. So like we see
Mhm.
the curves. And mm, my idea was to see, there is not an idea. So there is a notion. It calls the elbow curve when you see like the speed of changes, and basically when the speed of the changes is more flat, then
Mhm.
you decide to work with the data where the flatness starts. Like it goes like that, and you can do the trade-off where the curve speed
Um,
uh,
Starts
it's
to
it's lower, yes.
right.
So but here like we kind of can say maybe like it's at point 6 it's already like,
Right.
see like speed here it's higher than in this case, but
Mhm. Right.
it's not very obvious. So
Yeah.
like and so like in this case I just printed out the uh points right here, right? So like for the counts 0, we have like at 0.5, we have 37K, at 0.6, 25K, 16K, 9, 4, and like for 162K, and so on. Just to have some numbers in front. And also I was trying to calculate absolute and relative differences to see like what is the speed, like how what is the speed of the change of every point. And I basically um, it just for us to understand like what's going on with the information. Yes, right here. So then, oh my gosh. Okay, what I'm doing. Okay, counts. Okay, second. So, okay, so now we plotting counts and percentage share percentage share of evident and non-evident across confidence levels. So like what we can see, right? So like here non-evident, that's the absolute numbers, and this is how we it is by the by the percentage.
Mm,
And
okay.
in this, yeah, so like I plotted two charts together for non-evident and evident, so we can kind of like visually compare the speed of changes. Let's say if we have here is non-evident, and the speed of changes it just goes down. Not, I'm sorry, not for the changes, but for the um, percentage share. For non-habitants goes down, but for the habitants it goes up. So it means
Mhm.
like if we have like 100 counts for both non-habitant and habitant, when the confidence levels goes up, then we have the share of habitant is going up as well,
Okay.
and the share of non-habitant it goes down. And So yep. Uh, and here we can see yeah, that's actually kind of, in my case, maybe I'm wrong, but we absolutely have to discuss it. So I was trying to see like the share of both evident and non-evident across the confidence levels. So like, and
Okay.
as we can see, the total accuracy, right, or like in our case, the total average mean goes up for total data set from 0.76, 75 to 0.97, I guess.
Hmm.
And at the level zero point 0.7, the share of habitants is the same as average mean. So it could be a
Mm,
trade-off where we can see like the data is kind of at the same point, and it means the influence of non-habitant is minimal.
right. Okay, that makes
Yeah,
sense.
yeah. So in this point, we can talk about we can at least we can let's say provide the argumentation why we can choose zero point 0.7 level
Hmm.
and not zero point 0.8 or zero point 0.9.
Right.
Yeah.
Okay, yeah,
So
I like that. Yeah.
yeah. So and yeah, actually, so like I printed out the accuracy at confidence level is 0.86, like 866, and where the share of habitant, right, 1 and 0 is for habitants is 0.86 and for non-habitant 0.14. So the accuracy for all confidence level it's almost the same as the share of habitants. And also the accuracy it was just
Mhm.
for myself, for me. So like 0.5, 0.6, 0.7, 0.8, 0.9, that's the mean average. um yeah, total that's is very, I mean, it's equal, it's equal. Yes. So like at that point I decided to work with zero point 0.7 data set. We can discuss it, of course, like if we find out like something else. So like, and I just wanted to start with something, and if we decide to work with zero point 0.8 or zero point 0.6, then it's got to be the same approach.
Right. Okay.
So
Yeah, I
yeah,
like that. I think that's good.
okay. So like
Um,
that's the EDA. So right now our data set it's data at zero point 0.7 confidence level. And
okay.
in this case, as we decided, so we don't need uh, class 0 or non-habitant because we don't care anymore.
Right.
That's the misclassification. So I dropped them, and this like, and right now I started to run all these functions in the beginning. So the visual data. So in this case, it just, let's say, shows us how many observations we have. So that we have a little bit more than 100K observations. Uh, we can see like okay, scrollable. So we can see like um, first 10 rows. It can be 5. It doesn't matter actually. So we see like we have no duplicates. We have no missing values. Some statistics. And we can see like in general, Western crowned warbler uh,
Is the most common bird,
is the
right?
most common,
Yeah.
yes, and yeah, so the common name, and also uh like PSL2, right, or lower level
The
is
lowest,
also
yeah,
like
have the
kind of,
most birds.
yes. So we have the starts, ends, confidence, like so zero point 0.7 and go to the up. So months, and we can see here like the majority of the cases it's in if it's in June, not May,
Hmm.
not July, but June. So it's a kind of also um, an insight. And birds used to sing from 5 to 7. Mostly no one singing at 4 or at 8 or 9. So that's also
Hmm.
like, like the insight we can put it on. And the latitude starting from 33.142 up. And as we talking about the longitude is like just you see some peaks, some spikes at 76 450, and also like a 76 455, some spikes. And for the elevation, it's kind of interesting because like the majority of the cases, right, are like in between uh, mm, 32 and 34, but you also have some spikes at let's say 300, like 3580, I guess, something like that. We have to figure out. Then the matrix, the blue color says like that's the negative correlation, and the red color is the positive correlation.
Right.
Yeah. So like, and this is the so like this explore data set function. So this let me do that. So I just run the sorry. So it goes for the unique values and the value counts. I mean, for the end and start doesn't make sense. But let's say, yeah, for the value counts for the names. So you see like 41% is Western Crown Warbler, and Hume's is 19. So like as we can see, like let's say here like three three birds here, they are like what, 60 70, almost 73% of all the birds,
Right.
like three quarters. That's a lot.
That's
So
what,
like
yeah.
so it's also like data inside, and we can put it in our analysis. I haven't done it yet. I just wanted to show because like I mean like
Yeah, yeah, yeah.
yeah. So like let's go. The confidence level doesn't matter. Column. Oh yes. So like, as you can see here, like the value counts mm, for our data sets, right? So like you see, like the majority also like it's low elevation. Like all
Right.
elevation is almost like 30%. Like three of
hmm
them, almost 30%. So and there is no high elevation at all until but in the end the majority is like high elevation. So it's
Right.
also like inside, and we can just show like with the numbers, like the low elevation, blah blah blah, the high
hmm
and the medium, yeah, and also like the value counts for the months, like more than 55% is in June. So
hmm
probably that's we can also make the assumption that's
Like
the
mating season or something.
exactly, yes. So
hmm
like they try like to
Right.
attract, to mate, like and do like all the stuff. Or like just make sure the area is um occupied. So
hmm
for the days, it's almost the same. So like it doesn't matter like where like what day they do the song. So it's almost the same, like from 4 to
Right.
like 2. Yeah, it doesn't matter. For the time, as you can see, like 90% of all the songs are between 5 and 7,
hmm
but we have 489. So that's also like and yeah, and the latitude. So like we can see like the majority, like it's right here. We can work on it as well, because I have to see like what it means in reality. Like where is it? Maybe we can do some mapping. I don't know yet. So same for the longitude and for the elevations. Yes, like here, like from like three, like 20%, even more, like 22, right? It's like from at the elevation of 3,300. So it's quite interesting, I
Yeah.
guess. So and
Oh,
then
yeah.
habitant, yes, that's 100. So okay, that's uh, so we can get a lot of information from this data. So exploring the songs. So like and by songs we mean intervals more than 3 seconds. Actually, it's gotta be yeah of the same species. Okay.
Right.
Yeah, it can be like 3 seconds as well. So like you run that file, and I saved it, uh, and then you go same visual data. So it says like let's see. So we got what we got 15K observations, right? In our case, still like 50% of all the songs, it's about this bird. So like it likes to like sing. Then the months, it's almost the same actually. Uh, but let me go to the data set. Yes, okay. And actually, I haven't done this yet, but I probably have to do like the. Oh yes, actually, let me see. We have to do like the length of the songs, like as like average like 6 seconds or 8 seconds. I have to adapt a column actually. So yeah, that's all this information. Uh, yeah, that's months. It's kind of the same, and I'm adding up the information about the length of the songs. So and okay, oh my gosh, 1 second. Okay, okay. So that's um. So if we do, so I already saved this data set, but actually um, why I commented, because it takes about 10-12 minutes to get all this data. Just it takes like a long time. So I've just like
Right.
I saved it and run like that. So like we are trying to understand who's singing before and after Hume's Warbler.
Right. Right. Right.
Yeah. So like, and you can see like a lot of data. Like I'm sorry. So and probably event start. Okay, we have to do this exploration, all this stuff. So yes, that's the same. Like mm, then the next one is exploring who's interacting within same within the same audio chunk.
Okay.
Same audio chunk. Same 3 seconds. Okay. Anyway, yes. So in this case we have 1,300 observations, and so like those spikes. And also I ran the, okay, that's the exploring the data set. And also we can see, so within 3 seconds, actually Hume's Warbler, that's the one who's like, who interacting the most. It was
Okay.
kind of interesting. And then I was trying to see like the pairs, right? The pairs. So, and we can see, so like the majority of the pairs, it's like what, like 1/5, 20%
Oh
of all
wow.
the pairs is Himalayan bluetail
Himalayan
and
blue
Hume's
tail.
Warbler. Yes, that's a lot. And actually, Hume Warbler just like meets like here like a lot, right here, right here. So like these pairs, like within 3 seconds, are also kind of so like we can say to Pranav, okay, we see like who's interacting, who's trying to
Right.
yeah, and then what uh yes, right. So and in this case that's the pairs with Hume's Warbler only. So like yeah, that's it. So probably can depend on each unique pair. Yes. Okay, let's see. Yep, perfect. Yeah, so that was my analysis. So like I have to adapt some columns for the songs like lengths and see like what could be the observations. But that's pretty much I had so far.
Okay, cool. Yeah, it looks really, really great. I think it'll tell us a lot about um confidence levels, where to set it, everything. I know that was like a big pain point for us trying to figure it out. So that's good. No, I like that. And yeah, tomorrow we can show, because tomorrow we have the meeting with Pranav, right? We
Yep,
can show
yep.
him all that.
Absolutely, absolutely. So, and then we just can tell them like we need some a little bit more time and just put it everything on the paper. So like yes, like we understood the data set, we made some decisions, we can do the assumptions, we can put the point why we've done that, and just because we have the data limitations and we don't understand some stuff. But yes, absolutely.
Okay, perfect. And this is all in your
Yes.
branch, right?
Yeah.
Okay, cool. Sounds good. Tomorrow I'm going out of town, so I won't be able to make it to tomorrow's meeting.
No
But
problem.
I can watch the recording. Um, yeah, just let me know if there's anything that we should do after the meeting tomorrow with Pranav. And I can
Absolutely.
start putting stuff together. Um, and I don't know if you want to, whenever you're finished with the, or if you want to do more to it or leave it as is, but if you want to post on Teams and then maybe Marco or Anand can add any feedback that they have on that too. If you want, you don't have to.
I mean, absolutely, absolutely. They are experts, and like sometimes they can just tell us, okay, guys, you're missing this or that, or you
Hmm.
just focus on something else. Because he also, like, by him, I mean Marco, he also promised to uh, show us some social network, like graphs
Oh
cases.
yeah,
Yeah,
and
and
statistical tools too, right? I remember him saying that.
yes, exactly. And like right now, we kind of know like the um social networks of Hume's Warbler because
Hmm.
we've done some pairs, right? So we know like within 3 seconds and after, like so like who's trying to interact. Uh, mm, it could be helpful because the graphs is actually it's quite a cool um, mathematical notion. So and we can
Hmm.
work with that absolutely.
Yeah, I think so too. Okay. Uh, cool. Is there anything that you want me to work on or do? Um, I can do my own analysis that I did last time, but I feel like yours is more comprehensive. So I don't know if it would be redundant for me to do that as well, or
So like honestly, it's up to you because like I mean like it will be awesome like if we adapt something from your analysis, like some
okay.
charts or something else because that's the teamwork, right?
Right, right,
So,
right. Okay.
but mm, it's up to you, and like in this case, I'm going to update the notebook as well, just making some summaries because I guess then uh, when you gotta put like everything on the paper, so like you just can use like all the summaries. Like let's say like
Mhm.
I'll put it briefly, and you can expand text, just adding up like some explanations.
Okay. Okay. Cool. And let me know when you update it, and I'll take a look at it again. And um, yeah,
Definitely,
I'll try to do some analysis outside of what you've done. I mean, you've done a lot already. I'll try to find some other things that we could take a look at and show. And maybe you can show that to Pranav tomorrow if I do it before I leave. Um, cool. Okay.
absolutely, yes. I will do, but they will need so they will need more visuals. They will need more
Right.
charts. That's like another step because like right now because like all these pairs or like all this information it's kind of I would say useless if you cannot provide the visuals.
Mm-hmm. Mm-hmm.
Yeah, because I understand, you understand, but
Right.
probably yeah, because
Yeah,
like we
people
are
need.
like yes, right. So and I hope we can finish up at least like 90% by the end of this week or like by the beginning because like next week I would like to start the machine learning part of the
Yeah.
project.
Yeah, I agree.
Yeah,
Okay.
so yeah.
Okay. think that sounds good. Cool.
Okay, so let me know if you need anything. Just
Yeah, likewise, likewise. Sounds good.
okay, perfect. Then
Great.
have a nice trip tomorrow, and we talk on Tuesday. Or if anything else, just hit me, and we can um have like a call anytime.
Okay, sounds good. Sweet. Thanks, Andre.
Thank you, Vanessa. Bye bye.